All right, so today we're factoring expressions, okay? Does anybody remember what we learned in 3.3? Anybody remember what we learned in the lesson right before this that you had a worksheet on yesterday? Distributive property, okay? So I'm going to kind of shift over. This is not in your notes, but I want to show you how these two sections connect, okay? So let's say this is distributive property. Okay, 2 times 3x minus 4. So in section 3.3, we learned you cannot combine the 3x minus 4, right? They're not like terms. Does everybody agree? Yeah. You can't combine them. So what do we have to do? Multiply 2 times 3x and 2 times negative 4. What's 2 times 3x? 6x. 6x. And what's 2 times negative 4? Negative 8. Okay, and that was our answer. All right, everybody agree? Everybody remember what we did in 3.3, distributive. So now here's what we're going to do today. We're going to do the distributive property in reverse. Your original problem would say 6x minus 8. And I'm going to teach you today some tools to recognize a common factor that would exist between these two terms. Does everybody agree that 2 is a factor that goes into both 6 and 8? Does everybody agree? So because I have a common factor of 2, I could pull it out, divide it by the original, and look what I end up with. Okay, you just have to trust me until I can get through the lesson. I factored this expression, and this would be my answer. Okay, so here's what I want you to see just for now. Factoring expressions is the distributive property in reverse. Okay, that's what we're doing today. All right, so you need to know some terms. You guys remember GCF? Greatest common factor? GCF? Yes? GCF? Okay, so GCF is really important with factoring expressions. You have to be able to find the largest common factor between two numbers. Don't worry, it's not going to be like up in the hundreds, okay? But you do have to find the largest common factor. And then, what does it mean to factor an expression? It means to pull out the common factors between two terms, Okay, so make sure you fill in those blanks. All right, there's two ways to find GCF. Sometimes we think that we know the common factor, but we might not know the greatest common factor. So how can you double check it? All right, now I will be all for, we don't have calculators still, okay? I'll be all for you doing this mental math. You say, oh, I know the biggest number that goes into both of them. That's fine, but what if you don't? What if you think you know, but you're not sure? There's a way that you can check it. All right, did you guys learn upside down division? You guys know upside down division? Here's our main rule for upside down division. I have 30 and 48. I must divide by what kind of number? Starts with a P, a prime number. I must divide by a prime number. You say, what's a prime number? This might not be the method. Okay, a prime number that you want to use. Actually, I don't prefer this method anyway for factoring. A prime number is a number that only has factors of 1 and itself. So, well, I'm still not sure. If it's an even number, it's going to be 2. Just start with 2. If it's an even number, divide it by 2. You must divide by prime numbers. Okay, 2 goes into 30 how many times? 15. What's next? What's a prime number that can go into 15? 3, very good. How many times? 5. As soon as I have a prime number on the bottom, I know that I'm done. This is it. Okay, now let's do 48. 48's a little longer. We can start with a 2. 24, 2, 12. What goes into 12? 4 goes into 12. Does 4 work? Yes. Is 4 prime? No, I can only divide by prime numbers. Let's do a 2 again. 6 and a 2 again, and now 3. And again, once my bottom number is prime, I'm done. Okay, So this is a review of GCF. Okay? You say, well, what was the title of the lesson today? Is the title of the lesson GCF? No. Okay, it's not. So this took a little bit of time, didn't it? And this is not even really what I'm solving. So this is why we don't prefer this method, but we still are going to practice it. So here's my last step, okay? I need to find common factors, a group of common factors between the two numbers. Is there a factor that is both in 30 and 48? Samuel?
4.
No. A factor. Okay, Hadley?
6.
No. Look, the number's on the outside, okay? I was trying to avoid listing them. Again, because this is not even the preferred method. Just tell me, what's a common factor?
2.
Okay, 2. 2 is a factor of both numbers. And 3, you see the 3 here and the 3 here, one group of 3s. So my rule says for GCF, I take each set of common factors and I multiply them together to get the GCF. Okay? 2 times 3 is 6. That's my GCF. So I think that's what we were trying to answer, but remember, how do we get there? Okay, so the other method is not factor trees. I think I despise those even more. Okay, it's not factor trees, it's listing factors. Okay, this is your easiest and your fastest way. All right, especially because in this section you are not going to have huge numbers. You need to use upside down division if you're dealing with really, really big numbers. I don't want to have to list all the factors of 340. That would be ridiculous, wouldn't it? Okay, that's when I use the upside down division. Simple numbers like this, here is your strategy. Again, this is if you are unsure of the GCF. I almost guarantee you in some of our classwork problems today, you're going to know the GCF without doing this. That's okay. But what if I don't? Here we go. Pick the smaller of the two numbers. Does everybody agree? Hopefully that 24 is smaller than 40. Everybody agree? Okay, so here we go. 1 times 24. I'm looking for the largest factor of 24 first, which is 24. Does 24 go into 40 evenly? No, it does not. So now I need to go to my next set of factors. 2 times what equals 24? 12, okay? So here's my next biggest factor. Does 12 go into 40? No, so I need to keep going. Does 3, yes, 3 goes into 24, how many times? 8, okay? So does 8 go into 40? Yes, so I can stop at 8. 8 is my GCF, all right? And this is something that you could do pretty quickly. You might even be able to do this whole part of it, mental math. But you need to go biggest to smallest. Because, look here, guys. 24 and 40. Isn't 2 a common factor? Isn't 2 a common factor between those two numbers?
Yeah.
Isn't 4 a common factor? But it's not the biggest one. So if you don't pick the biggest one, you're going to get the answer wrong, even if you factor correctly. That's a bummer. Okay, you with me? Okay, so finding GCF is really important. Please just use this, okay? Upside down division has its place, but not in this lesson. All right, I almost wish I had just taken it out, but it is good just to review that because it is important. All right, so here we go with example 1. In example 1, I need to factor out the GCF. You have a section on your homework like this, meaning I need to factor out the largest factor between these two numbers. Okay, well, if you want to double check, again, if you want to risk it and just say, oh, I think I know the biggest one, all right, you're probably going to be right. But to be 100% sure, I'm going to take you through the steps. Which number is smaller? 18. So here we go. 1 times 18. Does 18 go into 28? No. Here we go. 2 times 9. Does 9 go into 28? Nope. 3 times 6. Does 6 go into 28? Nope. All right. And then does 4 go into 18? Does 5 go into 18? Okay, so the next factors of 18 are 6 times 3, right? So because that's repeating, I know that I have listed all of my factors of 18. There has to be a number here. You need to start at the biggest number and work your way down. It's not 18, it's not 9, it's not 6, it's not 3, it's 2. You say, well, I could look at that initially and I could know 2 is the only common factor. This right here is not a mandatory work to show. Do you understand that? You don't have to show your factors. But there's one problem on your classwork that you're about to work on your own. You might get that wrong if you don't show that step. Okay? Because I had people last hour not show their factors and they got it wrong. All right? So that's just my encouragement to you. I'd rather take a couple extra seconds and make sure I know the GCF. So now that we know the GCF, now we can factor. The biggest number that goes into both of these numbers, I know is 2. So I'm going to pull it out. And now, to determine what is left inside the parentheses, remember guys, this is distributive property in reverse. The numbers are together. I'm trying to pull out the biggest factor between them. So now I take my original numbers and I divide it by the factor that I pulled out. What's 28 divided by 2? 14x. Okay, we bring down our common variable. What's negative 18 divided by 2? Negative 9. And I'm done. Okay, so you pull out your greatest common factor. You divide the original numbers by that factor. What's left goes inside. Follow me? Okay. So now let's do the next one. I want you to figure out the GCF, figure out what you're going to pull out. Okay? This one's a little easier because your smallest number only has a couple factors. What's the biggest factor of 4? 4. Does 4 go into 20? Yes. Boom, there you go. You didn't even have to show any work on that, guys. You know you're pulling out a 4. So what's 4 divided by 4? 1. Bring down your y. What's negative 20 divided by 4? Negative 5. All right. This is the factoring. You say, man, we spent a lot of time talking about GCF. Yes, because you need a tool to fall back on if you can't figure out the biggest number that goes between them. Okay. So that is important, but sometimes they're pretty simple like that. And you're going to find that on your homework too. All right, so I want you to do these two on your own. That D should not be there. So let's go ahead and erase the D. Sorry, I guess I just hit a button. Okay, go ahead, factor out your GCF out of this expression and box in your answer. Okay, I'm going to give you about 2 minutes to do this on your own, and then we'll pair up and compare our answers. Everyone together, what factor did you pull out of the first one? 5. And what's left inside?
3.
Perfect. Awesome. Good job. Now, on the second one, class, what factor did you pull out? 12. Does everybody agree 12 is not the only factor that's in common? But it is the biggest one. So if you say, oh, 2 is a common factor, that's not the biggest one, so you're going to do all your factoring, and it's not going to be correct. 12 is 3c plus 2 is inside. Okay, how'd you do? All right, from what I could see, you guys did great on that, so that's awesome. All right, so we're not going to stop there, though. Now we have fractions and decimals to look at. All right, this looks a lot scarier than it really is. There is a simple strategy that you can use that can turn something that looks intimidating. How in the world am I going to pull out a fraction, GCF, and then figure out what's left inside? Okay, here's your strategy. Factor out the smallest fraction. You do have to be able to tell which one is smaller in value. There's also a strategy there. The smaller denominator will be the smaller fraction. However, like here, they both have the same denominator. So when it's the same denominator, the smaller numerator is the smaller fraction. Okay? So because I have a denominator on both, does everybody agree 1 is smaller than 3? Yes. Okay. So 1/2 is the fraction I factor out. When you look at these, you will be factoring out one of the two fractions. You factor out the smaller of the two. So we will pull 1/2 out of this expression. Okay, here's the good news. Whichever one was the smaller one, this is easy. Any number divided by itself, what's 1/2 divided by 1/2? 1. Any number divided by itself is 1. So all you have left is 1x. Now you will have a little bit of work because you do have to divide the second term by the fraction you factored out. So you will do 3/2 divided by 1/2. Does anybody remember what you do when you divide fractions?
Yes.
KFC. Guys, the good news is these will stay simple. They're not going to be overly complicated, but you do have to KFC. Look what happens. Cross reduce. What's 3 times 1? Plus 3. And you're done. Okay? That's the easiest I can make this, okay? So I do have to deal with some dividing of fractions, but I only have to do it on one of them because the other one that I pulled out, I'm just dividing by itself, okay? All right, I need you to look at the second one. All right, don't say it out loud. I want everybody to think in their minds, what is the smaller of the two fractions? Don't say it out loud. You can raise your hand if you think you know it. I will be calling on somebody. Okay. Aiden? Yes, 3/4, not the P, because we're only looking at the numbers. How do I know? Because 4 is a bigger denominator. The larger the denominator, the smaller the fraction. Okay? So the denominator, goodness, I couldn't get that out. So I pull out a 3/4. Well, I want you to try to figure out what's going to be left inside. I'm going to give you just a minute. 1p. Did you guys get 1p?
Yes.
Okay. 3/2 divided by 3/4. What do we have to do? KFC. So now it's times 4/3. Here's the great thing, and this is going to happen, all right, because again, these are not complicated fractions. They do just want us practicing our rules. Cross reduce. What's -1 times 2? -2. So if I have a mistake, you probably put +2. Okay? But remember, it's -2 because it's a negative times a positive, 1 negative. All right? Okay, how do we do on that? Maybe it wasn't as hard as you thought it was going to be. Pull out the smaller fraction. So guess what we're going to do on decimals? Pull out the smaller number. And it's probably going to be the decimal. Okay? And honestly, I might even rephrase that just to say, factor out the decimal. Okay? Whichever number is the decimal value, say, what if they're both decimals? Factor out the smaller one. Okay? So in this case, both of the decimal values are the smaller number. What happens when I pull out my decimal value is this. I pull out, does everybody agree 2.5 is smaller? Okay. Okay. So I am going to have to do some dividing. If I don't know what 5 divided by 2.5 is, I'm going to have to divide it. But do we know 5 divided by 2.5?
Yes.
Okay. If you don't, you need to do the long division, which we're about to do on the next one. All right, so I'm going to give you this one. It's 2. Hey, guess what? Good news. Any number divided by itself is what?
1.
Plus 1q. I'm done. Okay. You just pull out the smaller of the two. 2.5 divided by 2.5 is 1. So now let's do the next one. What's my smaller of the two numbers? Values. 3.5. Okay, so in this case, again, I'm factoring out the decimal value. Now, if the smaller number is the whole number, I still factor out the smaller number. Okay, you still factor out the smaller of the two numbers. So pull out the 3.5. All right, now, most of you can't do that in your head, 42 divided by 3.5. So that's where you would do long division. Okay? Can I have a decimal in my divisor?
No.
Nope. So move it. What happens to 42? No. Got to add the 0.
Oh, yeah.
Okay? So now it's 35 goes into 420. 1, 35, 70, and 12. Okay? So 12 is that number. Oh, there we go. What's 3.5 divided by 3.5? Plus 1h. Okay? So if you run into some division that you can't do mental math, just do the long division. Again, look guys, it's not going to be super long. I promise you. Okay? It will not be a repeating decimal. It's not going to be this ridiculous decimal. It'll be real quick. Okay? All right, because again, that's not, the lesson is factoring, not long division. All right? Negatives. Now, the benefit to pre-algebra versus algebra 1 and algebra 2, they tell you what to factor out. So on our negatives, you're going to see, they're going to say, factor out this value specifically. Okay? And that's the number that you write on the outside. Factor -4, perfect. I'll pull out a -4. Easy enough. I don't have to figure out the GCF. It tells me what to factor out. All right. Now, I need to figure out what's left inside. Does anybody remember? How am I going to figure out what's left inside? How do I know? I pulled out the number that they told me to. How do I know what's left inside? Divide. Divide that number by the original. What's -4? Watch your signs. What's -4 divided by -4? 1. Divide. Divide. 2 negatives, even odd rule. It's +1. Okay? Now, anybody know 10 divided by -4? Okay, you say, I didn't know it was 2.5. Just do your quick long division. Okay, 10 divided by 4. You'll see a 2. Bring down your 2, a 0.0. And you'll see it's 2.5. Okay, if you can do that in your head, by all means. Minus 2.5. And that's your answer. Okay? Does everybody understand how I figured out, stop, how I figured out the numbers that were left inside the parentheses? Everybody understand? Okay, I want you to do the last one. This is the last one we'll do today. I'll save the challenge question for tomorrow. It's not on your homework, but it will be on your quiz and test. So the modeling real life we will cover tomorrow. We pulled out a -5. Everyone together, what is left inside? 1D minus 6. Who got that right? 1D minus 6. Okay, very good. All right, guys. If you understand that, aside from the modeling real life, which we will do tomorrow after your quiz, that's everything you need to know.